Hi, this lesson is about chain rule. In order to understand chain rule, we have to understand composite functions. So a composite function is a function of a function. These are two common notations. They're read as f of g of x. So I usually use this one here. For example, if I wanted to know what f of g of x is when f of x is square root of x minus 4 and g of x is 3x plus 2, that means that the g of x is the input into the variable for f of x. So it would look like this, the square root of g of x minus 4, but we know that g of x is 3x plus 2, and when you combine the 2 minus the 4, you get that f of g of x is the composite function square root of 3x minus 2. Okay, if I use the same two functions but did the work in the opposite order, g of f of x, that means f of x is the input to g of x. So square root of x minus 4 replaces the x in g of x, which is what I wrote here. But we know that f of x is the square root of x minus 4. There's nothing else you could really do at this point because you can't combine your constants here. One is inside the radical, one is not. You can't distribute because of the radical. So your composite g of f of x is 3 square root x minus 4 plus 2. So when you're working with composite functions, you're going to need to be able to identify which one is the outer function and which one is the inner function of a composite. So with something like this, I have h of x equal to the cube root of x plus 1, and that sum is squared minus 3. So cube root of x plus 1 is inside of the function that's being squared. So we would consider g of x to be the inner function. And then the outer function would be squaring that expression and then decreasing it by 3. So we'll need to be able to identify outer and inner in order to apply chain rule. So let's see, what does chain rule look like? So if g of x is differentiable at x and f of x is differentiable at g of x, then the composite function f of g of x, which we're calling capital F of x, is differentiable at x, and the derivative f prime is f prime of g of x times g prime of x. So in other words, with chain rule, when you're taking the derivative, you have to take the derivative of the outside function first and then multiply that by the derivative of the inside function. And the inner function stays the same when you take the derivative of the outside function. So let's look at examples. We want to find y prime for y equal to the square root of 2x plus 7. So here, I know that I can rewrite this as 2x plus 7 to the 1/2. The outer function is raising it to the 1/2 power. The inner function is 2x plus 7. So remember, with chain rule, you do the outside first. So because my outer function is an exponent, something raised to an exponent, I'm going to use power rule. So that's this piece right here. This is the outer derivative first. It's 1/2, the exponent goes to the front, the inner function stays the same, raised to the negative 1/2 power. That's this part of the formula, times the derivative of the inside. Now the derivative of the inside function is just times 2. So that's this part of the formula. And then at this point we can simplify because the 1/2 and the 2 cancel, and I could rewrite this expression with the negative exponent and put it in the denominator. I also wrote it as a radical. So my final answer is just 1 over the square root of 2x plus 7. All right, let's look at another one. We want to find the first and second derivative of f of x equal to sine of 2x, and then evaluate the second derivative at pi over 8. Okay, so this is also a composite function. The sine would be considered the outer function, and the 2x would be considered the inner function. So remember, we start on the outside first. The derivative of sine is cosine of 2x, and then the derivative of 2x is 2, so I just went ahead and put it in the front as a coefficient. So f prime is 2 cosine of 2x. But I now have to find f double prime, which means take the derivative of f prime. So now it's 2 times a composite function, where this time cosine is the outer, this is the outside, and this one is the inside function. And that whole thing is going to get multiplied by the 2 in front. So the derivative of, so let me just do an additional step here. I just went ahead and put the answer. So this will be 2 times, the derivative of cosine is negative sine of 2x, times the derivative of the inside, which is 2. When you put that all together, you have to multiply 2, -1, and 2. So that's why I have -4 sine of 2x as the answer for f double prime. Then I have to evaluate it at pi over 8. So you plug in pi over 8 for x, and we know that this one, 2 times pi over 8 is pi over 4, but pi over 4 is equal to root 2 over 2. So when you multiply -4 times root 2 over 2, these cancel, and that's how we get an answer of -2 root 2. All right, so let's see, what's next? We want to find the slope of the tangent line to the curve of f of theta equal to sine squared of theta at 5 pi over 6. Remember, sine squared of theta could be rewritten as sine of theta to the second power. So that might make it a little easier to recognize what's outer and what's inner. So squared is the outside part. The sine of theta is the inside part of the composite. So remember, we always start with the outside function first when we're taking the derivative using chain rule. So the derivative, chain rule, would be 2 sine of theta to the first power, so we don't need to write that, times the derivative of sine, which is cosine. So it's 2 sine theta cosine theta. Now I'm ready to evaluate it at 5 pi over 6. 5 pi over 6 has a reference angle of pi over 6, which is a 30-degree angle. So again, that's one we should know. 5 pi over 6 is in quadrant 2. So we need to know that as well so that we know what sign, what plus or minus to put in front of these answers. So the sine of 5 pi over 6 is just 1 over 2. That's a 30-degree angle. And sine is positive in quadrant 2. But the cosine of a 30-degree angle is root 3 over 2, but in quadrant 2, cosine is negative. So we get negative root 3 over 2. And when we combine everything, multiply all these numbers together, we get a final answer of negative root 3 over 2. Okay, so here we want to find the equation of a tangent line to y equal to tangent of 3x at pi over 12. So remember, to find the equation of a tangent line, we have to find the slope and we have to find the point. Now I know part of the point. I know the x-coordinate of the point. We can easily find the y-coordinate by just plugging in pi over 12 into my function. And that's actually what I did here on the right. When x is equal to pi over 12, y is equal to tangent of 3 times pi over 12, which is equal to the tangent of pi over 4. Remember, pi over 4 is a 45-degree angle, and the tangent at 45 degrees is 1. So the point we are going to use is pi over 12, 1. So let's find the derivative, because the derivative will give me the slope. So to find the derivative, I do have to use chain rule. The outer function is tangent, and the inner function is 3x. So the derivative of tangent is secant squared of 3x times the derivative of 3x, which is 3. So I now have to evaluate 3 secant squared at pi over 12, which means 3 secant of pi over 4, and then we're going to square that result. The value of secant at pi over 4 is root 2. and then we square it. So root 2 squared is 2, and 3 times 2 gives me a slope of 6. So I use that point and that slope in the point-slope formula. So I get y minus 1 is equal to 6 times x minus pi over 12. Distribute the 6, and you get y minus 1 equals 6x minus pi over 2, because the 6 and the 12 will cancel here. And then add 1, and you get the equation of your tangent line at that point is 6x minus pi over 2 plus 1. So you really can't combine these because one is an irrational number and the other one is an integer. But basically the y-intercept of this line is negative pi over 2 plus 1. All right, let's do another one. So this one is a little bit more complex because we have 3 functions that make up this composite, not just 2. So when I rewrite it like this, cosine of 4x to the third power, the third power is your outer function. The cosine is the middle, and 4x is your innermost function. So what that means is that you're going to have a little bit more to keep in mind when you're doing chain rule. But chain rule, you always work from the outside towards the inside, because we'll have the outer, the derivative of the outer, times the middle, the derivative of the middle one, times the derivative of the innermost one. So let's start with the outer function first. That means I put 3 in front, and I take 1 away from the exponent, and everything on the inside stayed the same. Then I take the derivative of the middle function. The derivative of cosine is negative sine, and again, that inside part, the 4x, stays the same. Then I take the derivative of the innermost function, which is 4. So with chain rule, you're just multiplying. There should be no addition and subtraction between all of the expressions that you are putting together. These are all getting multiplied together as you go from outer to inner. Then I have several coefficients. I have the 3, I have this negative 1, and I have the 4. So my coefficient will be negative 12, cosine squared of 4x, sine of 4x. All right, so here's an example where on the surface it might look like quotient rule is the best choice, but you can actually avoid quotient rule, which actually kind of takes a little bit long and definitely takes more space on your paper. When your numerator is a constant and pi cubed is just a number, it is a constant, you can avoid using quotient rule by rewriting the expression and just using chain rule. So what I mean by that is, instead of pi cubed over the square root of 1 minus 3x, I'm going to write the square root as 1 minus 3x to the negative 1/2. Then pi cubed is just the coefficient of that variable expression, and I'm going to apply chain rule to this part where the outer function is raising it to the negative 1/2 power and the inner function is 1 minus 3x. So that's exactly what I did on this line. This is now y prime. The negative 1/2 goes in front, and you subtract 1 from the exponent, and then I take the derivative of the inside, which is negative 3. So all of the coefficients combine. So the negative 3 and the negative 1/2 multiply together, as well as the pi cubed, and I get 3 pi cubed over 2 times 1 minus 3x to the negative 3/2. But then writing my negative exponent in a different way without the negative exponent and as a radical, I get 3 pi cubed over 2 square root of 1 minus 3x to the third. You don't have to rewrite it as a radical. Another option would be to write 3 pi cubed over 2 1 minus 3x to the positive 3/2. So all 3 of these, this one, and this one, are all equivalent, just written in different ways. All right. In this example, we can't just avoid quotient rule very easily. In fact, if you do want to avoid quotient rule, you still can, but you'd have to use product rule. And the difference is because my numerator is also a variable expression, it's not a constant like the last one. So quotient rule is an option. I did this one with product rule by rewriting my denominator as 1 plus 4t to the negative 1/3. And then I used product rule on these two expressions. So here I let f equal 2t squared, and I let g equal 1 plus 4t to the negative 1/3. F prime is 4t, and g prime is negative 1/3. 1 plus 4t to the negative 4/3 times 4. So I applied chain rule to this part. So we know that gives us, this will give us negative 4/3, 1 plus 4t to the negative 4/3. Okay, so this information is now on this line. So from this point forward, this is r prime. So we get g f prime, or no, I did f g prime because with product rule it doesn't matter. So f g prime plus g f prime. So that's what we get here. Then it's a matter of simplifying. So from this line to this line, I multiplied the 4 and the 2t squared. That's where the negative 8t squared came from, as well as this negative. That's why it's negative. The 3's in the denominator along with this expression. I moved it down to the denominator and changed the exponent to positive. And then here, all I did was I put this in the denominator. But that means that I need a common denominator. So when you work with product rule to avoid quotient rule, you do have to do a little bit more algebra because now you have to find an LCD. And the lowest common multiple is the first one. It's 3, 1 plus 4t to the 4/3. So in order to get that into the second fraction, I have to multiply numerator and denominator by 3 times 1 plus 4t to the first power, which is the same as 3/3, so that I could add these exponents here. So that then gives me a common denominator on the next line. But it also means that I can combine all these numerators, which is what you see here. So the 3 and the 4 combined, which is where I get 12t, and then I just have to distribute that 12t across the 1 plus 4t, which is what I did on this line. So you get negative 8t squared plus 12t plus 48t squared over the common denominator. These two are like terms, so I get 40t squared plus 12t over 3 times 1 plus 4t to the 4/3 power. You're essentially done at this point, but it's always a good idea to factor because sometimes something will cancel. So I factored out a 4t, and that leaves me with 10t plus 3 in the numerator. Nothing cancels with the denominator, so essentially these last two answers are both acceptable. All right, so that's it for chain rule. Chain rule is a really important rule, so practicing, you'll get better at it. The next part of the lesson in this section is about the slope of a tangent line to a curve that's expressed in parametric form. So this might be a new concept for you. When x and y are expressed in terms of a third variable, and that third variable is usually t, oftentimes t stands for time, although it doesn't have to, we say that x and y are expressed in parametric form, and the variable t is called a parameter. So not only are we dealing with x and y, we now have this new variable t to be concerned with. So if x of t is expressed in terms of some variable t, then x prime of t is the same as dx dt, the derivative of x with respect to t. And if we express y as a function of t, then y prime of t will be dy dt. So when you have a function expressed in terms of x of t and y of t, so in other words, in this parametric form, when you're asked to find the slope of that, the slope of the tangent line to that curve expressed in parametric form, then your slope will be dy dt divided by dx dt. So it's basically the ratio of these two. So let's do an example. If the horizontal distance x that an object has moved is given by x of t equal to 3t squared, and the vertical distance y of t is given by 1 minus t squared, find the slope of the tangent line when t is equal to 2. All right, so that's exactly what we're being asked to find. Find the slope of the tangent line, and my curve is expressed in parametric form, x in terms of t and y in terms of t. So that's right here. So dx dt is just the derivative of 3t squared. So that's just power rule, that's 6t. And dy dt, that's also power rule, that's negative 2t. So when I evaluate them both at t equal to 2, you get that dx dt is equal to 12, dy dt is equal to negative 4. So the slope of the tangent line is dy dt over dx dt. So negative 4 over 12 reduces to a slope of negative 1/3. Okay, here's another. Find the slope of the tangent line to the curve defined by the parametric equations when t is equal to 1 of an object moving such that its x and y coordinates of position are given by x of t is equal to 1 plus 2t and y of t is equal to t squared minus 3t. Well, dx dt is just 2 and dy dt is 2t minus 3. So if I write my slope in general terms, it is now dy dt over dx dt, and then substituting t equal to 1 into your slope, you get that your slope is negative 1/2. Okay, here's another. Find the slope of the tangent line to the curve defined by the parametric equations when t is equal to 4 of an object moving such that its x and y coordinates of position are given by x equal to square root of 1 plus 2t and y equal to t plus t minus t squared. All right, so we know that when you have a radical, you want to rewrite it without the radical. So x is 1 plus 2t to the 1/2. But that means that we have to use chain rule in order to find dx dt. So it's the derivative of the outside function first, that's 1/2, 1 plus 2t to the negative 1/2, times the derivative of the inside function, which is just 2. And when you simplify dx dt, the 2's cancel, and I'm left with dx dt is 1 over square root of 1 plus the square root of 1 plus 2t. And dy dt is 1 minus 2t. So when I write my slope in general terms, this is going to be dy dt divided by dx dt. But we know that when you're dividing by a fraction, it's the same as multiplying by its reciprocal. So the slope in general terms is 1 minus 2t in parentheses times the square root of 1 plus 2t. Now I'm ready to substitute in 4, which is what t is equal to. So I get 1 minus 2 times 4, which we know is negative 7. And then here I get 1 plus 2 times 4, which we know is the square root of 9. And when you simplify square root of 9, that's 3. So my slope is equal to negative 21 for those parametric equations at t equal to 4. Okay, so that's it for that lesson. Give the homework a try. Good luck.